signed up for this.
That's awesome. So cool.
Nice.
Cool.
We're already seeing comments before we even start here.
What's up, everybody? Smooth music right there. I like that.
I was just about to say, I
Takes
love
me
that.
back.
Yeah, I better drink my whiskey right now. So
I don't know who chose that on the Coalesce side, but they deserve an award. That was nice, little smooth music. Welcome, Joe and Matt.
yeah, what's up? Good to see you.
Good to see you too. It's been a while. We were saying in the backstage, since we have a super elaborate backstage on these calls, that
It's nice.
in the past, Joe and Matt interviewed Satish and I, and this is our turn to turn the tables and interview you two. So I'm pumped. Looks like we've got a bunch of people who registered for this. They must be really excited to hear you guys speak, as I can imagine. So we're already seeing some comments come through. I always love seeing where everybody's logged in from or dialing in from. It looks like we got Russell Lowski from Jacksonville, North Carolina. A bunch of other people mentioning just a nice hello. We got Stuart out in San Francisco.
Looks like.
Yeah.
I hope not. Yeah. We're stuck at the airport right now. Not great news this morning.
He did say
what better way to spend your time at the airport than tuning to the show?
That's true.
Right?
Yeah.
So,
now you have time to hang out.
It's the best layover show you can think of. So
that's awesome. We got Dan Scott. Hey Dan, hope you're well. We got some people logged in from Belgium, Cincinnati. Love to see it. Omaha, Nebraska. We got somebody saying, "Hey,
my hometown."
Somebody just finished your book this week, Joe and Matt.
It's good. I don't know if you read it. Thanks for reading it.
If you have questions or errata or anything like that. Yeah.
So I can't display it. But
that'll be the main topic today. We're looking forward to diving into this. I've read through the book, and I was telling Joe and Matt, it's one of the most comprehensive summaries of data engineering and everything that anybody should know that's either in the space as a practitioner, marketing in the space, selling in the space. Really is just a shortcut to understanding all the most important concepts and pieces when it comes to data engineering in general. So I certainly loved it. I remember when we first met, you guys were just about to publish it. So it's cool to see something tangible with your names on it.
Well, thank you. And it's also cool to see, you guys blowing up too. I think it's awesome. So we have our collective successes, and it's awesome to see.
I think we were all kind of hustling back then. We were hustling to get the book done, basically. And
you guys are hustling, get the business up and running. So
yeah, exactly. We had just came out of stealth, so yeah, we're still hustling. Let's don't
stop that part. Yeah,
as I'm sure you are too.
Yep.
That was fun.
Yeah, the book. I mean, going back to the book, I mean, it's got great depth and breadth. It covers so many topics. I mean, there are a lot of terms that people are not aware of. What is Lambda architecture? What is, all those things they'll explain in the book. So this is
the field has changed so fast, even in like the last decade, that it's been really hard to keep up with all these developments. And so, but it wasn't intended to just be a history book, but obviously you need to know the context to understand how things work now. So
the best part I like is you guys put in, you explain the terms, you explain the architecture, and then you add your advice. Hey guys, this is what we advise. This is how you should do it. I mean, that's amazing. That's a lot of value for anybody reading the book, understanding what, because you can read a lot on the internet, but at the end, you don't know what, there's no distilled way of getting all that information and putting it into practice.
Right.
But
On our Monday show, we were kind of talking about this. I feel like both in data science and in data engineering, there's sometimes not enough kind of high-level conceptual advice. And some people on our Monday show actually push back on that. But I guess my point is, it's not that you don't need to learn tools in detail and programming and everything else. but you need to learn the big picture of like how architectures work together. If you don't do that, then you're going to spend a lot of wasted time just spinning your wheel doing.
Well, in fact, I see this as like one of the biggest problems that we see with data teams is it's not really a lack of tooling per se, or advice. It's really having the knowledge and kind of the standardized competencies on a data team where everybody's sort of, if you say something, people understand what that means, right? And it's like there's a playbook for how to do certain practices like that. That's really missing. And what we find is that causes that lack of knowledge, and that lack of standards really causes a lot of inefficiencies with data teams too. So, my hope for the world is, this book, hopefully progresses some of that knowledge with data teams. So they just feel like a lot of the problems that I keep saying over and over, technology is, and to some extent that's an issue, but in a lot of cases, just like knowing what the hell you're doing. So
yeah. It's clarity. I think it's a book that's focused on adding clarity to what is unfortunately very convoluted space. There's a lot of misinformation. Yeah. There's a lot of money that gets poured into technologies and vendors that say certain things that lead you in the wrong direction. I think we all have certain examples of that. Different technologies we've seen that kind of took the analytics space a step backwards, only for it to then go 2 steps forward.
Yep.
And so. That was the thing that was most interesting for me, just, being able to see, like Satish said, a distilled way of a lot of this information to just really quickly consume and understand really important topics. So I got a question for you guys that I've been thinking about. And if anybody else has questions, feel free to hit us up in the chat. We're monitoring this as well. But my first question was, obviously we talked about how comprehensive this book is. Is there anything in it that you wish you knew sooner or had learned earlier in your career, like very specific items that you recall where you're like, damn, I wish I would have knew this a long time ago?
Well, that's interesting. I feel like a whole lot of stuff, but I'm trying to pick out real specific examples. I mean, one thing we talk about a lot in the book is the evolution from big data to just like the modern, I don't love the term modern data stack anymore, but like modern cloud-based systems, the current era. Yeah. And I think those of us who sort of started our careers working a lot on Hadoop maybe stayed on that stack too long, realizing that all the ceremony around Hadoop wasn't going to be necessary for most applications. There are exceptions, but for most applications within a couple of years. And it was really much more important to focus on fundamentals like data quality rather than quite so much low-level coding.
Right. Yeah, I think the things that I wish I would have known earlier was just the when I got into data engineering, it wasn't really called data engineering, right? It was just like, I think it was software engineering or data science. Data scientists are expected to do a lot of what I guess data engineers are supposed to be doing. The whole 80% of the time for a data scientist is spent like gathering data, cleaning it, all that kind of fun stuff. Like that's what a data engineer should do. I think the chapters that stood out to me that and I think they're the fun ones, right? And also the hard ones was like the one on architecture. Like that's one where I feel like architecture is just one of these words where everyone says it and nobody is quite sure what it means. So if you ask somebody with the word architect in their title, what is architecture? And just sit back and, let them look confused for a second and try and figure that out. I mean, that's happened every single time I've asked an architect about what architecture is. It's not a knock against anybody. It's such a, it's just one of these terms. I think it's very, it's defined, but it's not really defined.
Yeah.
You know what I mean? So that, and then chapter 4, I think was interesting where we talk about choosing technologies. I think that was a really good rubric for understanding how to evaluate the trade-offs of different technologies. And these are really, I mean, that chapter was really written from, I think, a lot of lessons that we'd, learned in our business and also in our, jobs before we worked together is really how do you evaluate technologies and what are the trade-offs, right? I mean, this is a huge thing where we talk about the notion of one-way and two-way doors, right? And so, you want to try and make reversible decisions with your architecture and your tools if you can help it. If you, we think we see a lot of companies that have gotten, I would say, stuck, and to put it very politely, into some technologies and architectures.
Yeah, and I think also the chapter on choosing technologies was a lot about this, what Joe likes to call shiny object syndrome, which To be frank, a lot of the Hadoop era revolved around shiny object syndrome. I mean, for certain applications, Hadoop was fantastic, but there were so many companies that just adopted it because it was the cool new thing. And like data science is cool and it's going to solve all your problems. And then it turned out that that was not the case. And they ended up kind of stuck in this quagmire that was hard to get out.
You mean like getting big data tools when you had like gigs of data? And that was like, because I remember back when big data was popular, everyone's like, yeah, man, I mean, I got like a terabyte of data. And I'm like, that's cool. Like my phone has about that.
Yeah, my laptop's got that. Yeah.
It's like, it's funny, you know, it was definitely like a pissing contest. I remember when big data was out because people didn't realize, you know, the 3 V's behind it, or maybe the 4 V's if you want to count value. But it was people were looking at it literally like, well, I got big data, you know, yeah. But you fast forward today and it's like, yeah, it fits in like a thumb drive. That's cute. You know, so.
And then running core company processes in some cases on MapReduce, and so you had this like very brittle, unmaintainable MapReduce code that's really creaky. And you know, back then everyone was saying, "Oh, this MapReduce is the future, and no one's going to be writing SQL in a few years. No one's."
Yeah, I remember those arguments too. SQL's dead. Data warehousing's dead. All this stuff. Data modeling's dead. Yeah, Kate Graziano says data modeling there. I mean, everyone's saying, "Oh, data modeling is dead," and I think to some extent people still will say that, like, oh, you just need one big table. We can talk about modeling in a bit, but it's on. Yeah. But I feel like that, you know, these are the sorts of the concepts too, where I feel like, you know, one of the aims is really just to consolidate and make people aware of this stuff, right? I think that it's to your point, Armon and Satish. It's like there's a lot of vendor noise out there. Not you guys, obviously, but you know, there's a lot of convolutions of terms and of practices that I think are really self-serving, and the problem is, you know, what's missing in the discussion is, you know, the fundamentals, really the best practices, like the foundational stuff. If you go back to first principles, what are they, right? That's what we attempt to cover, right? And an example, it amazes me how many people are now just learning about dimensional modeling and data warehousing. This is something where you would think that's table stakes, but I mean, so people are like, "Who's Kimball?" I'm like,
we had Chad Sanderson on last month, and it was so funny because we were talking about how there's all these startups and companies, private companies, very well funded businesses that have all these data people, but they don't know what a star schema is, or some of the more fundamental concepts associated with data engineering. But they have crazy amount of data people, and they're all just doing ad hoc analytics and thinking that that's the way to be. Whereas but they move quickly. Whereas on the flip side, you've got enterprise businesses that do understand these fundamental concepts, but they move so painfully slow. And so we're starting to see a little bit of a convergence where the startup folks are now under a little bit more pressure financially to be a lot more economical and efficient. And so they need to think about things like architecture, proper data architectures. They need to think about things like data modeling, building out a blueprint or logical design. And enterprise are under some pressure to deliver more efficiently as well, instead of moving so painfully slow. So you know, you talk a lot. One of the reasons that I really enjoyed meeting both of you guys as we came into Stealth, Joe and Matt, was we instantly clicked around data modeling and data architectures. Like those were two things.
Yeah. That's
like long lost siblings or something.
Yeah. I mean, I think you guys saw. I mean, we had a whole discussion about why you founded the company, and I think it was a lot of the same problems that we that led us to the book. Yeah.
And we feel like, you know, the industry is going through the same, like repeating the same mistakes. You know, why Kimball kind of proposed that model in the first place, to solve certain problems, you know, with the agility and, you know, having a model kind of explain how you can use this model to generate all kinds of analysis out of it. And here we are doing the opposite again, you know, which is like before Kimball, we're repeating the same mistake. And now we're coming back to it. And so it just seems like a cycle that's just
it's a total cycle. We went through like a cycle.
Yeah.
No, we always talk about pendulums, right? So it's kind of like, you know, I kind of describe it as a pendulum between fast and formal, or speed versus rigor, or, you know, or something like that. And it's really, you know, you can do things fast, or you can do things, you know, well. It's and it's kind of an interesting dichotomy too, and it's maybe a false dichotomy in the sense where if you can do things formally and do them right, eventually you can move faster, right? So it kind of equated to if you're a runner. Like you're going to spend most of your time probably in doing zone 2 training if you're running, right? Like the slow, boring stuff, 80% of your time should be spent doing that. most people, I think, are tempted, oh, well, if I'm not getting a good workout, if I don't feel like I'm going to die, I mean, I'm going to do wind sprints, right? But it's like, you want to get good at running, you're going to go slow. And it's the same with a lot of other things in life. Like, you know, if you adopt the practices, you know, there's no sense of reinventing the wheel. It's already been there. And in a lot of cases, like dimensional modeling has been around for a long time. It works great for OLAP systems. Why don't you do that? Relational modeling works really well for OLTP. And, you know, that's been around for a long, long time. And, you know, and it's not like these are like hidden secrets of the universe. Like there's plenty of material out there and very famous books, right? But we see this with us application developers too. You know, relational modeling is also one of these things where it feels like that's, you know, sort of a lost art in some ways. Somebody mentioned NoSQL. That's definitely a piece of that. You can't really do relational modeling in NoSQL, but
I mean, but what is funny though is that we've seen people do quasi-relational modeling in NoSQL by using ORM systems, and so you have a NoSQL software running on NoSQL,
like Mongo
doing joins
allows you
behind
to
the
do that.
scenes.
Yeah,
That's crazy.
and Mongoose.
It's like the worst of both worlds.
Yeah, because you're trying to join these like Mongo collections together like a psychopath. So, but that has downstream effects though, right? So I'm actually working on a new book on data modeling, and the route I'm taking is really sort of the data modeling life cycle, right? So if you start from source systems and go downstream, it's like the modeling, you know, the consequences of doing good modeling upstream, we're doing poor modeling upstream. Well, that has obvious effects downstream in your data warehouse and your streaming systems and machine learning and so forth. And it's like, it's a recognition that you don't model data in a vacuum. Well, most people do actually. I'll just say that up front. Most people do that, but the consequences are basically like, then all of a sudden you get you have to have all this tooling around. You know, the modern data stack now has any number of observability and quality tools. I think in a large part is a reaction to the fact that the data upstream, well, it's a giant question mark. Is it good or not? It's like going to a buffet. I don't know how long's the food been out. You know, it's a gamble. So. You know, you might have a good meal. You might be sitting on the toilet for a while. I'm not sure. So
too much information. Jeff,
yeah, but that's the same with data, though. You don't know what you're getting. I mean, it might be great, might be having a good time, or not.
So I totally agree. What do you think about how the future looks when it comes to data modeling, data architecture? I remember, Joe, you had mentioned that like the whole innovation around data modeling is kind of felt like it stopped. There's been a pretty big gap between some of the newer methodologies and where we're at now. Obviously, data mesh is becoming more and more of a common topic. What are your viewpoints on what the future looks like when it comes?
Let me come into this, and I'll kind of tell you what I'm excited to see in Joe's book, and it's that you have the data world kind of split into two camps, similar to what you're talking about. You had the startup people who were like very big data, throw the baby out with the bathwater, don't do any data modeling. And then you had the very entrenched old school people who were like, no, my religion is Kimball, or my religion is Data Vault or COD or whatever, or third normal form. This is what I do for everything. Yep. And the problem is that modern tools don't always play well with third normal form, for example. That doesn't mean that you should just denormalize everything. In fact, that doesn't even make sense. And so we do need some ideas that can like modernize, like learn Kimball, but also modernize the practices to play better with modern tools and modern practices.
Well, how I address this too is that, I'm not going to tell you what to do. Like I'm going to give you the trade-off of like, if you don't want to do anything, because I also consider a lack of a data model to be a data model itself, right? Mm-hmm. At some point, you're storing data to represent the reality upon which the data is, supposed to represent. But besides that point, it's like, sometimes it's situation dependent. Sometimes you got to move fast. Sometimes you want to take a step and do things more formally. And the whole thing is it's about the trade-offs, right? If you, if you don't want to take sit down and do it right the first time, you're probably going to have to come back at some point and do this. Yeah. You might not, I don't know. But there's no free lunch in this situation. And also, as Matt points out too, there's a lot of things I would say that the traditional modeling techniques don't capture, which is things like streaming, right? And to some extent also the impact of data, the modeling on preparing data for machine learning, right? These are two areas where I feel like they're seriously underserved, and haven't really been discussed at all. When you talk to people in the streaming camp, it's like, well, we don't really model the data. We just sort of just throw it in there and see what happens, right? And that's why Chad's working on data contracts, sort of help fix this. Upstream changes do have an impact, it turns out. But then you also have ML, right? And data scientists again spends a lot of the time having to go through data, and how do I feature engineer this, right? Or if it's text, like what's the corpus of the text? How do I embed it? All these other things, right? So I think it's providing, like, the thing I find that's really missing in the field is data modeling is one of these areas where I feel like it's super religious. I've rarely seen a field where there's such strong opinions held strongly, and what that means too is I think it really holds back the field, and there's a lot of gatekeeping, right? So
it's polarizing.
It is polarizing. I got a lot of flack when I mentioned I'm writing a book. Everyone's like, "How dare you write a book on this?" And I'm like, "Yeah, but you ain't writing a book on this, so just shut
up." Somebody needs to.
Yeah, I'm like, you gonna do this or not? So and the thing is, I feel like it's there's a lot of gatekeeping, and especially as I look at the relational world, for example, right? There's a lot of people who say, well, everything needs to be this certain paradigm, right? That COD came up with back in the late 60s, early 70s, right? Because it's first order predicate logic, and it's set theory, and like how dare you try and do something different when it's logic and math that's been around for thousands of years. I'm like, well, I don't know, Matt's a mathematician. Has math changed since like 2,000 years ago?
Well, it's not just that, but like I come actually from the pure math world, meaning that we study mathematical problems kind of in a vacuum. Like they might be remotely related, for example, to problems in physics, but you're just interested in the math. And I think, third normal form and COD made a lot of sense for the types of databases we had at the time. But the thing about pure math is that you ultimately need to adapt it to the tools you have in the problem you're trying to solve. Like, you don't simply do the same thing all the time or stick with mathematical set logic purity when that's not solving your problem. And and
just to add to that, what we're talking here about is getting that modernization of the same ideas, but in the context of context, right? I mean, one example I come across is still, sometimes the modeling in that time and in the previous era, storage was expensive. So people were kind of paying a lot of attention to design in such a way to save on storage, but that's no longer that big of an expense, relatively speaking. Mm-hmm. So people, but they can't let that go, and they're always thinking about that taking storage. So that's not, that's an evolution, right? That's a new way of thinking. We don't have to worry too much about storage,
right? That's just it. I mean, it reminds me of kind of like 80s hair metal fans that still think Poison's like the best band ever or something. You know what I'm saying? Like, it's just people hang on to the past way too much. I mean, there's certain elements of the past you definitely want to hang on to.
Right? Learn from it, right? Don't ignore it. That was the problem with the big data era. It's like, none of that stuff matters anymore.
Right. It matters. It doesn't matter until it matters, right? And I kind of feel like so I view things in a very Darwinian perspective. So MMA is a really good example, mixed martial arts, right? So, before MMA, you had all these different martial arts. Like, you had your kung fu man, who's, he's obviously, got the secrets, and only he knows them. And if you try and fight him, he'll like punch you, and your heart will just like fall out of your chest or something like that. It's crazy. Like, you hear stories about this kind of stuff, right? The boxer who just, Mike Tyson, like, what would happen if you fought a wrestler? All this stuff sort of like happened when UFC came about. Yeah, like Vale Tudo in Brazil back in the day too. But it's like what mixed martial. The reason I like the mixed martial arts analogy is you really found out what works when you have to take very heterogeneous.
When anything's fair game, basically.
Yeah, except punching, in the groin and eye gouging and stuff.
Eventually we banned that. It took a while.
Actually, in the first ones, in Vale Tudo, they had no rules whatsoever. And you found out, but the things, but you consolidate on what works now, right? And
totally.
So you don't see a lot of people doing like crane kicks in the UFC. That'd be like ridiculous. You'd get your ass kicked in about 5 seconds. So it's like, but I feel like the data world really needs a similar, sort of. Wake up call, really, because I think it's easy to get entrenched into a lot of our habits and viewpoints. So and long live Bruce Lee. Ken said that. Jeet Kune Do. That's but that's absolutely true. I mean, that's a lot of my inspiration for and I think for the book that we wrote too. Is it's like get all the ideas out there, provide people with the advice and the trade-offs. And just let people decide for themselves. So you don't be prescriptive about this stuff. Like, maybe give a viewpoint, but say, Matt and I could be wrong. I mean, we've been wrong a lot. So,
Well, and you're in a rapidly evolving field, and that's the problem with the religious attachment to one particular style of data modeling. Like, study it all, and then figure out what works with the tools that you have chosen based on, make this technology decision based on actually things like business requirements and long-term viability and reliability.
But ignore the practices at your own peril, right? So again, in MMA, like you're going to ignore techniques at your own peril. Like, you want to have an edge in some way, right? But you ignore like all the standard stuff.
You even mentioned in the book that every 2 years you should reevaluate your technologies because the market moves so quickly. Mm-hmm. Every couple of years, just pop your head up, look at what else is going on, see if there's been some modernization or evolution in the space you're in. I love the MMA example. I'm definitely going to steal that from you, Joe. As a UFC fan, I think nice. as a fellow UFC fan, I should say, it sounds like you're certainly one, which just made you even cooler on my data thought leaders list. It makes total sense. It makes total sense. I think it's the right way to go about things. It's a pragmatic way of going about things.
That's all it is, being pragmatic, right? I mean, there's being dogmatic, I would say, especially as things change quickly, that's a route to being irrelevant. So
it's like obsolescence, basically. Yeah.
It's like keeping your mullet, like, but not in an ironic way. It's just like it's my style, man. So
yeah,
that's what I do.
To be fair, too, when we talk about how the industry evolved and storage used to be really expensive, and so you needed to do all this homework. I think the exact same thing happened with startups, where all these problems we talk about aren't really that big of problems if you have a small use case or a small project. Like, you don't really need to think about data architecture as much or data modeling as much if it's a tiny use case. The issue is, as companies become successful, those use cases expand, and then you got 100 more use cases, and then now you're trying to Band-Aid and duct tape and stitch everything together, and then you look up and realize that you've got a 100-person team and nobody knows what anybody's doing, and there's a bunch of silos, and it gets messy really quickly.
It really does.
You become the person you hate. That's what happens.
Yeah. Yeah. You have trouble sleeping.
When you start out, it's like, oh, I'll never have silos on my team. Like, we're gonna, we're gonna be really well run, and we're gonna communicate and collaborate, and everyone's it's gonna be great. Then you wake up one day, and you become your parents.
Silos.
Yep.
You can't look in the mirror anymore. It just gets really dark.
No, and you still got a mullet too. It sucks.
Yeah.
And driving your Trans Am.
It's a good car, actually. Should get one.
You should upgrade. Yeah,
I want like an IROC. That'd be fun to drive.
There you go. Yeah. In the snow, that'd be perfect.
Yeah.
So another chapter I loved was the future of data engineering. I feel like just scanning through a couple of these, like the live data stack going towards real time. As you can imagine, we agree wholeheartedly with the continuation of simplified and automated solutions, since that's exactly what Coalesce is focused on for transformations. What other trends are you seeing since writing this book, as you've been talking to all these other founders, thought leaders, that you're excited about that isn't in this book?
We had a conversation on Monday, which people can go back and watch, with Chip Wynn, and we were talking a lot about real-time machine learning and real-time model evaluation on streams. And it turns out these are still a big problem for most organizations that are still struggling to do machine learning in batch. So that's an interesting one. I'll be curious to see where that goes in the next, say, 2 years.
I think so. Yeah. That's a big one for sure. Yeah. Real-time ML, I think, is going to continual learning, as Chip calls it, right? I think it's a really big one that you're going to, but that kind of fits into the notion of the live data stack, right?
Does.
I think in general, the feedback loop between application, doing whatever you do with data and ML or analytics, like that feedback loop is just going to tighten and tighten and tighten. Like there's no reason, I think we subscribe to Flink's philosophy, the open source project of like, batch is basically just a subset of real time, right?
Yeah.
So if you think about data in a bounded and unbounded context, I think that really fits the bill. And so really just shortening that the delivery of value, and all that stuff, I think is like one aspect where we're excited. I think the other one is money. That it's obviously a big trend where as the book was coming out, you started seeing rumblings of I don't know, rates were rising, I think, as a book, but then it sort of like all came to a head, kind of middle of the last year there. And I think, you know, cost control is going to be a big thing.
FinOps is the kind of buzzwordy way to say it, but I think it's a very useful paradigm.
Yeah. As I'm staring at like my Warren Buffett bobblehead.
You're a big Warren Buffett fan, huh?
Yeah, I like. He's a cool dude. It's just his his Camaro. Just kidding. So, I think it's interesting because what I do like about him is he. Well, I mean, for a while he was written off, right, during the boom times. So everyone's like, oh, his way of doing stuff is obviously outdated because, but that's easy to say when money's like, being carpet bombed in the economy with zero interest rates and stuff. But, getting back to fundamentals, right? I think the thing I like about Warren is he's a value investor, a fundamental investor. And I think that's at the end of the day, like, focus on the basics, don't get fancy. Those are the things I really like about him and his approach. And I think that there's a lot to be learned from that, from everybody basically, but as pertains to data these days, it's just, I think it's a giant. I think the thing we didn't have in the book, which is I think you're going to see a lot more of just getting back to basics, right? Like,
focusing on fundamentals, can't go wrong. I really loved your blog post.
Money for something, I think it was.
Money for something. I appreciated that for the holiday break. I was going to ask, for some clarity for the audience too, when it comes to FinOps, like how would you describe that fundamentally? How would you articulate this to somebody who comes to Joe and Matt and says, hey, okay, I get it. Being economical is important. What does it mean when it comes to data?
I think the best starting point for most people, so it depends on what you're familiar with, but if you're already familiar with the notion of like DevOps, for example, so in the DevOps world, so first of all, your ops teams are very integrated with your software development teams, monitoring for bugs and problems, kind of send those over to software so you can get them fixed in near real time. You have continuous delivery and such, but also you're constantly monitoring the performance of your systems, right? So you do things like monitor how long it takes to respond to a request. How many users are hitting your site? How many clicks? How fast are you responding to those? How much CPU and memory are you using? Are you at risk of running out of resources? And so now let's take all of those practices and start applying them to cloud spend, because cloud spend is also essentially a real-time problem, right? So in the old days, you would order servers and they would show up 3 months later, and then you would install them and you would have the plumbers come in and install the cooling, and then eventually you turn them on. It was this very long process. But basically with cloud, spending has become real time, just as data is becoming real time. And so then you need to monitor that in the same way and say, hey, why am I suddenly spending so much money every second? What's going on? Like, has someone spun up, a massive Snowflake warehouse that's just driving costs through the roof?
Though, it's also about revenue, right?
And it's about,
how do you also monitor so you're getting an ROI on stuff, right? I think it's the other side of the coin.
That's right. So for example, if you realize that, hey, if I run this huge machine learning job and it spends a ton of money on Snowflake, but it's tied to a big bump in revenue because my recommender is better, that's totally worth it, right? So it's not just about squeezing out costs. It's about identifying your costs that are actually tied to value in various ways and not wasting money on things that aren't.
Well, and identifying what value is in the first place.
Well, that's tricky too, right? That's the tricky problem.
That's the tricky part. Yeah. I remember we were on a third of Samir Sharma this morning. He wrote about value, and I had another blog that sort of hinted at value. Value at the end of the day is sort of like, what does a customer define it as, right? It's literally
or the business owner. I mean, it's tricky, right?
Yeah, it's a customer, right? It's an internal. It's like, it's just how you define it and what's, are you getting benefit out of it and stuff. So that's a tricky one. Value is one of these terms where I feel like it's thrown around the industry like crazy. Everyone's like, oh, you got to get more value from your data. And I'm like, cool. What does value mean? It's like, I don't know. What is architecture? No idea either. So
it means something different to everybody. And it's like the value is so dependent on the stakeholders and the business and what they're trying to drive insight out of. But oftentimes they don't know what they don't know. And so it gets data teams into this mix. But I think one of the other things that was coming out of the conversation with Chad as we spoke with him was just this huge gap between the consumers of data and the producers, and how desperately needed there is to be more collaboration between the two.
Tons. Yeah. And he's doing a really good job of that. I think what he's working on with data contracts, I think is awesome, because it really, the interface between like software engineers and data teams, that's sorely needed. Right now, it's interesting too, because we all talk about agile, like, oh, we operate agile. One of the collaboration's an element of agile, but it's it's very much like throw it over the wall to the data team, and you know, then that's
See what happens.
Yeah. Like, whatever. I don't know. I'm not a data guy. Not my problem. Right? Because there's no feedback loop really at this point.
For sure.
Right? There's no sense. You know, you collaborate when there's a feedback loop between the conversation, right? Like there's a, you know, and then kind of conversation. Whereas right now it's like it's non-existent. It's very much a one-way thing. And so, you know, so I think things like what he's working on and is awesome. So I mean, it's just the first step, really. So we talked about data mesh earlier too. Like, you know, there's one of these things where it's now you have you know, disparate teams really, and there's you know, everything's decentralized. And so how does collaboration work in that? I mean, there's a lot of ways that could work, but so
yeah.
I got a question for you guys. So the old TP and all AP systems, do you guys see that those two type of systems converging into one type of database in the future?
I wouldn't say one type of database. I would say one pipeline. Let's call it that. And so this is this live data stack concept. And the idea is that in the old days, which actually is very much, this is still very much true
like last
in
month
many cases. yeah. But you on your app team, right? You design a schema, or maybe you just use ORM. You produce data, but you're not really thinking about analytics. You're like, that's someone else's problem. And so then that data in batch gets sucked in. You know, you do ETL, you post-process it, you send it into a data warehouse. The live data stack is about saying, okay, we know from the get-go that we want to do analytics on this data in an application, and it's probably going to be, you know, close to real time. And so let's start designing the schema for consumption from the get-go. We're going to make it work for the application, but we're also going to make it work for analytics. And then the pipeline, instead of just like sucking all that data out in batch, you just pass it right into a stream. And then you have a layer that sits on top of it that allows you to query it in your real time. And so that's the convergence. I mean, there are still multiple layers, but I think those layers will be more and more abstracted away so that people don't see them as much. They'll be able to use off-the-shelf tools to do a lot of these things. So that
or like single store, right? Like you know, kind of converging that, or Unistore, or I guess Aurora, Zero ETL, you know, was another example. So I think it's an area where it's really interesting. So I'm trying to figure this out, like if the market is driving this or if it's more of a game theory exercise, right? So when I look at what AWS did, I think that's more of that's more game theory in the sense where it's like, you know, we kind of have to have something at parity with Snowflake in order to keep up with them.
But that's just like the AWS tool proliferation, right? It's pretty haphazard because you have all these different teams creating new tools all the time.
Right. But, you know, it's, you know, I'm curious to see you know, what the actual adoption of these tools. I think the marketplace is the ultimate arbiter of these things. I think in some ways, though, like having the separate databases is just sort of like a comfort blanket for a lot of engineers, where it's like, this is my database. Now I get to share it with other people, right? But, you know, it's in some of these attempts, too, where I've seen some, you know, data teams have used the kind of the hybrid databases. And on paper, it looks like a good idea. But then, especially if you're on-prem, you got to deal with resource contention still, even though they claim that resource contention. It's like, you know, these are the conversations we have with these teams. And so, you know, the software engineering team needs to, you know, going to be bumping up a lot of the usage of, you know, this hybrid database here. And so, you know, there's some hard questions that have to be asked, right? Like, does our licensing fee go up now? What's it worth to us to do this? You know,
one system could be mission critical, you know, if you're supporting up, you know, and the other analytics system may be not, you know. Like,
well, the one trick that we're running into is that analytics increasingly is mission critical, right? Because it feeds back into stuff that faces the user.
Well, that's where I think it would be a good use case for that. You want the feedback loop to be shorter, but, you know, I'd say it's something you may want to graduate into. It's something I would probably start my startup off with like, let's use a hybrid database because we, you know, it's,
Although as it becomes easier, as you have these cloud tools that are,
it might just be a non-issue.
It might not be an issue.
And the other question is too, who's paying for it?
Yeah, that's right. Because these are inherently going to be more expensive. There are more layers.
Yeah. So is it the data team, or is it the engineering team, or is it? You know,
and that's where these FinOps discussions come in, and that's where, you know, when it comes to FinOps, you really have to communicate with the business about why they should be spending money. And we've had a couple of really great examples of IT failures in the airline industry recently. I won't name names, but a certain airline that really failed to invest in its IT infrastructure and had a complete meltdown. And today it was the FAA that had a meltdown, basically, right? And that's where the value is. That's where you produce value with IT, by not having catastrophic failures that disrupt all your operations. And this crosses over in analytics, where you have to be able to say, okay, where are my planes right now? And how do I get passengers from A to B? These are all analytics problems at the end of the day.
Right. Yeah, they say people learn faster when they lose money than
In a crisis. We learn from pain. Yeah, unfortunately.
We learn from pain. Yeah. Although I get way more excited about, data monetization practices and people actually being able to use their data as a gold mine without having to fall on their face first. But I guess sometimes that's just what markets require in order to develop.
Sometimes you got to hit rock bottom, right? I mean, I'm waiting for like the Dave Ramsey of the data world to show up, where he's like, clean up your technical and and analytical debt and data debt and all this stuff. And
well, the problem is there is this mentality that says that IT is a cost sink. And it's like, well, if IT is running your whole business, how much value is it generating? Like, ask the question, what happens if my IT systems go down? Does my business keep running? Probably not. Everything in your chain is IT. Managing customers, charging customers, taking orders.
But a lot of IT teams still, though, I mean, it's a difference between playing offense and defense,
two
right?
sides
And a
to
lot
this,
of these people are like, it's it's a cost sink because we report to the CFO. And guess what the CFO is going to look at, like just the bottom line, right? So I think it's a lot of it's, and that certain airline we talked about, like it was a good article that came out about how that company had just a culture. It was almost a cult in some ways, right? It was just kind of rah, very internal facing stuff and not focused on the customer at the end of the day. And I think that's largely the root cause of like why IT investment isn't there. It's like, well, I mean, does it help me? Does it help our cult? No. Okay, then why are we doing this? And so so it's as Charlie Munger says, right? Show me the incentive, show me I'll show you the outcome. I think this definitely holds true with IT investment and and stuff, but it all percolates down, right? So it's things like what kind of database do we use? Well, what kind of database can I use? But these decisions though largely come back to, okay, so how is the team structured as well, right? It's is engineering siloed? Is our data team siloed from engineering, and are we siloed from the business, right? Do we even know who the business is or what business we're in? I don't know. I mean, it's amazing. You sometimes see data teams where I'm not kidding. It's like they don't know how the company makes money.
Very common,
right?
Very common. Yeah.
It's like I just work here.
It's super common. They don't know what they're building. They're just kind of or who they're building it for. They've never spoken to that person or the consumers. It's a common thing. I also think a large part of IT and even infrastructure, like I talked to our head of infrastructure, and it's like at times can feel like a thankless job, but it's so critical to everything that happens in the world, particularly analytics, but also things like a airline, like a Southwest that hits some major issues and loses a bunch of money.
Mm-hmm. I mean, we all talk about data driven. Well, the reality is that like 99% of businesses now are data driven. Even a coffee shop has to rely on a payment system to like charge customers. They don't have that data, they do not make money.
Yep, definitely. I'm curious, from all the clients you work with, the conversations you have, what part of the analytics workflow itself do you see people or organizations having the most challenges with?
Where to begin? It's all over the place. In a lot of cases, it's a game of whack-a-mole, I would say, where it's kind of like you solve one problem over here, but it manifests itself over here in a different way, And so and I would say a lot of the root cause of this stems from not understanding sort of the holistic end-to-end life cycle. The data engineering life cycle, as we refer to it in the book, but not really thinking about things, okay, so like I'm going to do something over here, what are the consequences over here? And really thinking through that, from the beginning. I think in a lot of cases, it's the problems that we see is when, okay, I'll give you an example. When we see problems, it's like you keep tacking on new tools without really understanding like the big picture of like, what's this workflow? What's the output, right? So I get a bunch of inputs. What's the output? What's the product? I mean, you wouldn't make an assembly line that way for a factory, right? It's like, oh, I'll just put a bunch of like random stuff here, like a saw and a kitchen sink next to it or something. It's like, you want to, hopefully it makes sense. But all too often what we see with data stacks is sort of like a Rube Goldberg, kind of a setup. And, because again, I think a lot of that is, and maybe part of if it's the same data team doing all this, obviously they didn't take into account the big picture. In a lot of cases, though, it's like, different data teams or people working on different parts of the data stack, start getting very opinionated about their aspect of it, because that's, again, incentives and outcomes. If I'm incentivized to focus on this part of the stack, well, that's all I care about. I'm getting paid to care about this. I don't get paid to care about the rest of this stuff. Therefore, I don't really care. Like, you guys do your thing. But the problem is when you kind of try and glue this all together, I don't know. I mean, I don't know if you have any thoughts on that.
Yeah, I mean, there are many things that we could address with regard to this question, but one which is related to what Joe is saying. In 2022, there was this whole like online LinkedIn debate about, is the modern data stack dead? And I think what that really comes down to is what I'll call over democratization. So in other words, the tools got so easy that anyone, any analyst with no data engineering training could just get in and turn things on, and then you did end up with this just big spaghetti bowl mess of data sitting all over the place with no data model. And so I think the solution to that we're going to start seeing more and more, it's not really the fault of the modern data stack that this happened.
No, it's entirely, I'm just kidding.
It's more practices, right? It's just like, now we have to come back and say, okay, how do we fix this mess? Like, we have all this data now, we started from nothing. We actually need to create a data model. We need a data practice. We need engineering. We need to figure out what business requirements are.
Yeah, but I mean, again, though, it comes back to earlier point, though, when we're talking about like this knowledge and competencies and standardization, right? I think if you look at the root cause of like why this happens, it's not, again, it's people, process, technology, right? The technology is the last thing. Like, technology is really a consequence of like, either good or bad, decisions and processes and people along the way. Like, it's not like you just magically, technology doesn't like sprout, like mold spores or something. It's like maybe it does actually, I don't know. But in a lot of cases, like somebody decides to do this, right? But again, you got to give people a framework for decision making. This is what we come back to over and over, and why we decided to write the book too. The book. Some people were asking earlier, does this book exist? And I was like, yeah, it definitely exists. But in a lot of cases, it really does come down to just I would say the missing link that we see with data teams over and over again is like, it's the people and processes. Knowledge, skills, competency, standardization, collaboration, communication,
right?
All the stuff. But because you have the word engineer in your title, guess what the thing is that you're going to hate doing? All the things we just talked about. Because it's like, I want to engineer things.
Hack on code. You want to spin up new cloud infrastructure all the time. You want to play with the latest open source, right?
Right. It's a resume-driven development.
Yeah.
We call it.
And it's fun. That's why people get into the field. But you do need good practices, right? It's like back in the day, barbers would be the surgeons because they had really sharp knives. And obviously, at some point, we realized that we need training. My surgeon's
my barber, actually.
You do. You seem to be in good health.
Yeah,
so far.
Good haircut.
But
it's interesting. I mean, a bit ago we were talking about this, in the context of a sports team, right? Like, you wouldn't like form a sports team or train a sports team the way we train data teams. Right? You would have like a worst performing sports team in the world in most cases. You find the person, you have two legs and you can run, so you can be on my soccer team, right? And you can like kick a ball, so the person can kind of bounce a ball off their head, right? I mean, that's not. We look at certain skill sets and call those roles, right? But in absence of the bigger picture, like, is this person like coachable, for example, right? Can they listen?
Is there a playbook?
Is there a playbook? That's the other thing. What's the playbook, right?
Do we work together as a team? Do we have practices?
Bingo.
Do we communicate?
Yeah, Ted Lasso, really good show you should watch on the pros and cons of
data teams,
football.
Right?
Yeah, but that's the whole thing. Is it's a lot of it. The more I think about this problem, the more I'm realizing we don't have a tooling gap in the industry right now. I think, and if anything, it's almost like there's a lot of features disguised as tools.
And it's also a bit too easy sometimes.
It's too easy.
You can it's like you can go drive a car without a license. And I think that was Chris Tabb's analogy at one point. And that can be a big problem, right? We have training
without a license.
Yeah, that's kind of what we're doing, right?
Yeah.
Like you hand people these cloud tools without any training or practices.
Self-service
it's
just opened up access to powerful component analytics that were never possible prior to software as a service and the cloud. And now you've got access to this insanely powerful infrastructure and all these different technologies, but we often find that a lot of them don't enforce any type of standardization or governance into it. And then you got, just a rat's nest of code or a rat's nest of different components that don't speak well to each other, don't have, don't focus on metadata being a centralized concept around it. There's so many layers to it. that lead to these problems as projects get bigger, as teams get bigger, as tribal knowledge grows.
Yeah, totally agree. A really good book people should read is Team Topologies. I think that's a fantastic read. It talks about just it really looks at the so Conway's law, right? So Conway's law describes basically, you'll design systems according to the way that you communicate as an organization, right? So if you're really siloed, bingo, the systems you create are going to be like probably siloed. And but this is like an inescapable force of the universe, I think. And so team topology is really, is the intersection of Conway's law and domain-driven design. And I think I haven't seen this applied to data teams. It's another series of books I've been thinking about writing. But if somebody wants to take a stab at that, go for it. But because there are some, because the book is written for software engineering teams, but I think like 90% of the ideas in that book really apply to data teams. And I would really urge people to read that kind of a book, because it's not like if you are to do data engineering with Spark, it's like this is a more fundamental thing. Like, how do you structure teams to be successful? Like, this is a big thing.
I mean, this is like greatly tied into the topic of this whole LinkedIn Live, which is transforming your data engineering career. It's like, what are the characteristics of a great data leader? What is, like, from your experiences, what have you seen in someone that's been a kick-ass chief data officer or director of data engineering that you've appreciated, if anything?
I mean, it really is. It's a crossover job. That's what makes it so tricky to fill this role. You want someone who has enough technical understanding to know what the tools are and to be able to talk to the technical people who are
the patterns
and the patterns. Yeah, exactly. And also to stay current. That's hard, but also communicate with the business and say, what data do you actually need? What data is driving your business? What's mission critical?
I'd probably invert the question and probably ask, like, what are the attributes of like a really crappy data leader? I think it's maybe easier to describe.
It's a good place to start.
It's I would say it kind of leading to what Matt said. It's like if you operate in a silo, don't talk to stakeholders, don't understand what they need, don't empathize, don't deliver any value to what you're doing, operate in a bubble, that kind of thing. I think those are the attributes of leaders where I've seen probably haven't done as well. And I think what a lot of this is going to come to light too. It's sort of, what Buffett says about, when the tide goes out, you see you swimming naked. And I think right now with the, with the money kind of disappearing in the economy and for businesses and things under a lot more scrutiny, the data leaders that have, been able to deliver or have a game plan to deliver, those are the ones that are going to be around. And I would say that the ones that aren't are obviously the ones that aren't delivering value. So that's sort of, I would say, the blunt litmus test that will become very apparent now and in the foreseeable future. So
teams that just think smarter, not harder, or don't require many people to deliver.
I mean, you're operating at the times of great abundance means you can operate under a collective hallucination that you can do anything and you're free of constraints, and the times of constraints like now, it really forces you. I think it makes you better, to your point, Armon. It makes you better in the sense where you have to focus, you have to do more with less. And I think this is actually fosters more creativity and, just smarter ways of doing stuff. I think a lot of money actually makes you stupid.
For sure. It's irresponsible. I mean, like, to a degree, one of the reasons we're so passionate about our mission is to help accelerate development, help allow data engineers to be more efficient, enforce levels of standardization and governance in a way that just allows a business to get to value faster and be a lot more economical. Right. And in times like 2021, that's just not as big of a factor of importance, because you can go and hire 100 people and throw a bunch of bodies or invest millions and millions of dollars into some project. It's when things get challenged that I think it gets interesting, and you really see who has an intelligent approach about crafting and architecting their analytics workflow and their projects.
Absolutely. So. And the thing is, you focus on things that don't change. That's why I'm a big fan of inverting the question, actually. So, like, if you invert the, if you kind of focus on, like, okay, so like what do customers always want, right? They want things probably cheaper and they want it more quickly, and that's kind of an immutable law of the universe, right? I can't think of a situation where people want things more expensively and slower and of less quality and so forth, right? And with data, very much if you can focus on the true north, right? So is data believable? Can I trust it? Does it makes sense, right? Like that's Bill Inman says that's been his true north in his career for decades. And I think that's a really good true north. The other one is like, if it's believable, does it add value?
Yeah.
Right. And
Yeah.
that's if you can check those two boxes, I think you got a lot under control. If you can't, then maybe go back to question number one: is it believable, and then start over. So.
It is a nice catalyst for the market to evolve as well. When there is a little bit of pressure for people to think smarter and have to be more efficient, it does actually drive innovation a lot more quickly, in my opinion, than just pumping a bunch of cash into a problem. That's how things get solved really inefficiently, actually.
Well, this era, frankly, feels a lot like the .com boom and bust, right?
Yeah.
I mean, Joe and I are old enough to have been through that. And we saw all this money thrown at companies like pets.com that just melted down once it fell out. And now, but you also look, and some of the most successful tech companies were founded like either right before the collapse or like during the collapse, and just came out of it and were so strong because they were focused on customers. They were actually focused on making money as opposed to just better pitches. And so I think we'll actually see a lot of interesting activity in the startup space too around data, a real shift toward value and less.
You're gonna have better companies.
It was the trigger for us, Satish. I mean, when the pandemic hit, we were like, dude, let's do this. Nobody's meeting in person. What better time to build a product than when there's nothing going on?
When you managed to raise when everything was kind of, the money. I mean, I think it speaks volumes to, your vision and your mission and ability to execute.
Appreciate that. Or maybe just my ability to hand wave really well. Like
you got good hands.
Like
hypnotizing. I'm like, how much money does he want? I'll get him a check for whatever. So,
I think it comes back to the value prop of really focusing on these problems and being able to help people get to value faster. Like anytime you're doing something that brings down the TCO, which is another thing that I think a lot of data teams are neglecting, and I think we'll face in the future very soon if they're not already, is looking at the big picture of what does TCO mean first and foremost, and when you're choosing technologies, when you're making decisions, is how is it impacting not just the price of the product or the database or the tool, but how many people does it require to stand it up and manage it? And that's typically the largest cost. Is the resources, the human resources that go into some of these projects. And I think that people will start to focus on that piece a lot more as time progresses. So
yeah, for sure.
Whereas right now it's like, I think there's a lot of data teams that probably aren't even familiar with that term at all.
TCO, total cost of ownership.
Yeah.
In our book, we call out another one, total opportunity cost of ownership, right? So the cost is one thing too, what you see on paper, but it's, again, it comes back to one-way and two-way doors and reversible decisions. Like, when you go through a one-way door, a door you can't get out of, and it's like your opportunity cost is suddenly evaporated. And so, you want to keep your options open, especially now. You might be able to renegotiate a contract with vendors, except for Coalesce, they offer great deals all the time. So
price is going up.
It's a great price. It might be time to, but now's the time too when we probably want to reevaluate your total cost of ownership. If there are levers you can control, I would definitely urge exercising those, whether that's operating more intelligently in the cloud, again, best practices, knowledge, right? Or salespeople got to make their quota. So be friendly about it. You don't need to beat people up, but say, hey, we can get a better deal here. So
So definitely, we got a couple minutes left. I don't know, Steve, if you got a last question, or Joe and Matt, any thoughts?
Covered a lot of ground today already.
It's a teach though. It's like
I mean, I can talk to you guys all day. So.
Yeah, I mean, there are some audience questions. Maybe we should take those if there's something that we can cover.
Yeah, if we got room for a last one. I know there's a bunch of questions coming in as well.
Yeah, there's a lot. Yeah, happy to answer like one of them. Yeah, that'd be fine.
Let's see. I'm scanning through. We're getting some. There's one around your book. Somebody was asking.
I know Stuart already answered this, but I want to get your opinion as well. So AI is rapidly growing. What is a data engineer's role in the AI war?
Oh, yeah. So again, you jump back to our Monday chat with Chip. We actually talk a lot about the importance, and also her book is fantastic. And in terms of explaining why you need really good data engineering as a foundation for AI. Like all of these large language models, the data they trained on had to go through pipelines to get there. And you had to do various things to check its quality and making sure you were getting good data and making sure you weren't like ingesting a lot of horrible content that was going to create an awful model. Like all of these actually turn out to be very data engineering oriented problems.
Yeah. It's the bottleneck. I mean, like you can't do it without that component in place.
The foundation. I would also say like understand AI, like understand kind of the basics of it and what's expected. You know, I think a good data engineer should focus on the outputs, like the end outputs, right? So whether it's a report or whether that's you know, data that's going to be used for a model, like understand how these things work, right? So AI is one of these things where I mean, it obviously ain't going away anytime soon. So learn how it works. You might find too, you might like ML engineering better and ML ops, and maybe you can go work in that
well,
field.
It's kind of a crossover, right? There's a lot of overlap between data engineering and ML ops. And some companies keep them separate, but in some companies they're actually very integrated.
Yeah, but I would ignore it at your own peril too. It's like, again, it's just one of these things. I think it's just table stakes, like understand it. So
when we talk, I mean, we tried to write a timeless book, but AI is like sort of the wild card here. It's so hard to predict what the innovations are going to be in the next, say, 5 years. We've just seen crazy stuff in the last year, even.
I'm loving Chat GPT. Maybe not as much as Satish, but I think that's been our hack to getting job recs out for all the new roles.
Nice.
Chat GPT, tell us how to hire a new product marketing data engineer.
I think it works good for a lot of stuff like that. It was interesting. Somebody posted on LinkedIn last night about how they had a Chat GPT 3 try and do a simple multiplication problem of decimals, and it thought the decimals were probabilities. And so the response that came back was, you remember the earn problems from probability classes?
Yeah.
It's like, okay, so it's like you get four probabilities of, you know, it's like, oh, and you can get this one without replacement. It was like the weirdest answer I'd ever seen.
We probably shouldn't trust it with our lives just yet.
No, I certainly would not trust it with your lives or your homework at this point.
Well, I think one of the interesting things about AI is that it is so unpredictable. So they call these emergent behaviors. So in other words, these teams that started training these large language models didn't set out to create systems that could do math. But what they started noticing at some point is when you train them on enough data, and if there was math in that data, they would start to figure out math. It was like really bizarre. And so that's why I'm wondering, what are we
figure out math? It figures out the patterns of what the textbook said. Yeah.
That's what our brain, that's what we do when we're trained in elementary school too, on some level, right? But it's kind of crazy that this happened.
Well, when I looked at it, I was like, is this like how Common Core teaches math now?
It's probably right.
Probabilities. It's like to do simple multiplication. Yeah. So anyway, it's fun. Cool,
awesome.
Guys. Been fun.
Yeah, we're just at time. Joe and Matt, love having you two on. It was such an awesome opportunity. For those of you who are still wondering, if you didn't read the comments,
it's fake. It doesn't exist.
Yeah, check us out on Amazon.com.
It is real, I swear.
Blank pages up there.
Yeah,
that's right.
Thanks so much, gentlemen. It's always a class with you guys.
Thanks to the audience.
This was AI generated. That's what it was.
Yeah.
You're AI generated actually too. So.
Okay.
Thank you so much, guys.
Alrighty. See you guys. Bye-bye.
Cool.